So I want you to understand that your business is like a banana. This is Shigeo Shingo. He says 46% of it is waste. So that means out of every $100, $46 you spend is going for waste, rework, lost profit, patient harm. I mean, all this kind of stuff. So what you want to do is begin to solve problems. So I don't believe that you need to learn formulas. That's what the software's for. They've been the same for almost 100 years, so let the software do that. You don't need to know that. I also don't believe you need to learn decision trees. So if I can automate, if I can use a little bit of algorithms and some AI to look at your data, then I can help you pick the right charts automatically. And one of the things that is different about the QI macros is we ask you to select your data first. And if you select your data first, then when you click a button like the chart wizard, I can go look at the data you've selected and make intelligent choices about how to do the right charts from that. So you don't need to know everything. So all you have to do with QI macros is select the data and click on one of the QI macros wizards. So all you have to do is select your data with the mouse. So I have by month falls per 1,000 patient days, and click on the control chart wizard. And the control chart wizard will look at that. It says a single column decimal data that must be an individual's and moving range chart. And so it'll go ahead and create the XMR chart for you and pick it for you. And then you can see any out of control points are listed in red. You can see there was a downward trend here, which probably means we made an improvement. And as you can see, we have the QI macros menu up here, but once you click on a chart, that will actually bring up another menu, the QI macros chart menu. And under the QI macros chart menu, you can do all kinds of things like show process change, add target lines to chart, add text to points, reanalyze stability, do other things. But a most recent addition I put in here is the process change wizard. It'll look for trends and consider that to be a process change and recalculate the limits for you. And so here you can see we have a new chart which shows that we had improvements, right? So we went from 5.8 down to 4.56 falls per 1,000 patient days. So I'm trying to take people who know nothing about statistical process control and make it super easy for them to start drawing charts. So we have over 100 different fill-in-the-blank templates for everything from control charts to fishbones to value stream maps. And once you then get your data in here, you can just start entering the data, and your chart will grow as you go. One of the other things we can do is, if you have some data, like the healthcare data here, I can take that data, click on the control chart templates, and now we have a control chart templates wizard. And the control chart templates wizard will look at your data and say, what template should I use? It'll grab it out of our templates and then punch all your data in there and build you a chart. The fishbone diagram will pop up our template, and it's an automated template. So what you do is you come in here to the outline, and in here we're going to put in our problem statement. And then we can choose our large bars. So in healthcare it'd be this way. Manufacturing it might be that way. All right. And then we put in our first Y, second Y, third Y, fourth Y. And so I'm going to put in a manufacturing example here. This is from the ASQ, American Society of Quality. And if I click on Create Fishbone, it'll build me a fishbone diagram. And then if I want to say what's my root cause, I can circle that and show the root causes in red. Now I can also come back in here. Here's a healthcare example. I worked on insufficient ICU mobilization of ventilated patients. Again, once you get your YYYs in here, you can click on Create Fishbone, and it will build you a fishbone diagram. So at the minimum, you want to have the when, the where, the what. If you have the how and the how much and the who, guess what? That's even better. So again, if you have data that looks like this is denied insurance claims by hospital. It tells the where it happened, when it happened, what was going on. This was function code, and how much it cost. That could be worth $5 million a year. If you have data that looks like this in manufacturing, and again, here we see when did it happen, where did it happen, this is type of machine, type of scrap description, how much scrap was produced. That could be worth $1 million a year. I'm going to encourage you that this is where the big money is in data that looks like this. Now, one of the things that I did was I found that every multi-million-dollar project I ever worked on started with a pivot table. And that's one of the tools nobody teaches in Six Sigma, as far as I can tell. I've never seen that taught anywhere. But the idea is if you have data that's line by line, event by event, the when, where, what of what happened, guess what? The data mining wizard can take that, pivot it, turn it into control charts, Pareto charts, fishbones, and give you a complete improvement story. So it makes building improvement projects very simple. And it'll transform your data into an entire improvement project. So if we had something by date, by line type of defect, or in nursing, it would look more like something similar, by date, by nursing unit type of patient harm. What you can do is just select two of the headings up here, and you can click on the Data Mining Wizard. And the Data Mining Wizard will look at all that data and say, what can I do with this? So it'll pivot it, and then it'll say, can I make a control chart? Yes. So that shows us what's going on. And then it'll start looking through all of your examples and see if it can come up with Pareto charts and a fishbone diagram. So you can see it just took all that data, did the analysis, found a control chart. It found two projects. The first Pareto chart is like the 80-20 rule, where 20% of what you're doing is causing 80% of the waste and rework. But I've often found that that's not detailed enough. So it'll drill down into the big bar on the big chart and go to what I call the 450 rule. That means 4% of what you're doing is producing over half the waste and rework. For those of you in healthcare, the IHI set a goal of cutting costs waste by 50% by 2025. And I don't think anybody thinks that can be done. They're wrong, right? Because as little as 4%, that's like one step out of 25, 4 steps out of 100, are producing half the waste and rework in healthcare. Patient harm, all of this other stuff. So all we have to do is really come down, use a little bit of data, and you have data all about adverse events, let's say, or types of patient harm, or whatever. You could use that data and turn that into improvement projects. So here you can see it's created it, and down here on the bar below, you'll see each one of these. Now these are actually hot linked in here so you can get to them more easily. So injuries or whatever harm by date is 8.5. Then we're going to look down by unit, and unit 3 is 53%. So that's our 20% is causing 80% of the harm kind of a thought. But then we're going to go over within unit 3, what's the biggest type of patient harm in unit 3? Patient falls. So patient falls are 39% of the total. So what we want to do is, if we want to fix patient falls, we should work in unit 3, right? And go work on that with just those people. And then it'll build a fishbone diagram and create your problem statement. All right, so what it does here is take all of your data and everything it can find and builds an improvement project. But it doesn't stop there. All right? So what it'll do next is come in and do it the other way. It'll do it by type of harm. So we'll start with that. The big bar here is patient falls. Unit 3 is almost 80% of the total. So again, it's narrowed us down. It's telling us, Unit 3, fix this. All right, so, and then it'll create another fishbone diagram. So that's the data mining wizard. Well, you know, I don't think we should do quality improvement the way we did it last century. It was slow, stodgy, error-prone, takes too long. I don't think we can do it that way. It's just not possible. We have to go agile. We have to go fast, quick improvements.